everyone, welcome back. Let's do a recapture of what we've done so far for this week. Alright, so we dealt with two chords that intersect inside a circle, and when we do, we can set up an equation comparing one chord to the other chord, looking at their pieces. So once again, if I look at the first chord segment, this segment right here, it has two pieces, part A and part B. So you multiply piece times piece and set that product equal to, for the second chord, piece times piece. Alright, so A times B is equal to C times D. Then we dealt with circles that had two secants that intersect on the outside and they had a common external point. When this happens, we can form an equation. For one secant segment, you take the measure for the outside part and multiply it times the measure for the whole thing. To get the measure for the whole thing, we add outside plus inside. Okay? So the outside, A, times the measure of the whole thing, A plus B. And we set this product equal to, go to the second secant segment. Take the measure for the part outside, C, and multiply it times the measure of the whole thing. To get that measure, we add the outside part plus the inside, C plus D. And you have your equation. Then we looked at one that contained a secant and a tangent that met on the outside and had a common external point. I like to begin with the tangent. To form a multiplication problem with the tangent, we take the tangent measure and multiply it times itself. We square it. So the measure for the tangent squared, C squared, equals. Then we go to the secant segment, and once again we take the part on the outside, which is A, and multiply it times the measure of the whole secant segment. To get that measure, we add the outside part plus the inside, A plus B. And once you have your equations set up, you just simply isolate X, solve X. Okay? Now, let's go to a new lesson. Alright, for this lesson we're looking at segment lengths using properties of tangents. So given the figure below, prove that segment SP is congruent to segment TP. How do we prove that this segment TP has the same exact measure as segment SP? To do that, we have a theorem. First of all, we're given that the measure of angle PSO here, and the measure of angle PTO, this angle, they both have a measure of 90 degrees. And we're just going to accept that to be true because it was given to us, okay? But for step 2, it says that at this point we can show that the measure of segment SO is equal in measures to segment TO. So let's place some tick marks here. They're equal. But how do we justify that these two segments are congruent? If you look at them, they are both radii of a circle. So of course they're congruent. Why? Because write this down, all radii of a circle, as is a symbol, are congruent. And in step 3, we need to show that these two triangles have a common side. That common side is segment PO. And we all know that segment PO is congruent to itself. By which reason? This is by the reflexive property of congruency. Alright, so let's look and see what we have marked so far. We have right angles inside the triangles. They have a common side. And we have another pair of congruent sides. Therefore, I think we are ready to show that the triangles are congruent. So, before we do, there's one more thing. We want to change from congruency to equality. So, in other words, if segment PO is congruent to segment PO, then we can also say that the measure of segment PO is equal to the measure of segment PO. By which reason? This is by the definition of congruency. By the definition of congruency. And if that is the case, we can now show that, you need to add this to your worksheet, we can now show that triangle PSO is congruent to triangle PTO. We can now verify that the two triangles are congruent. We gave you 5 reasons that you could use to show that triangles are congruent. Which one of those 5 do we use here? Well, we have 2 right triangles, and we have proven that their hypotenuses are congruent, and a pair of corresponding legs are congruent. So we can use the hypotenuse-leg theorem. The hypotenuse-leg theorem. And if that's the case, now we can show that other corresponding parts of the 2 triangles are congruent. So, using CPCTC, we can now prove that segment SP, from point S to point P, has the same measures going from point T to point P. Alright, so these two segments are equal in measure because of this reason. Why? Because now you need to know, this is an established rule, that anytime you have a circle and you have two tangents, notice that segment SP is a tangent segment and segment TP is a tangent segment, and you have two tangents drawn to the same external point. Then from that common external point to each one of those points of tangency, you have congruent segments. So tangent segments now, not lines, tangent segments from a common external point are congruent. Let's write this down, please. And now we want to use this rule a few times so you can remember this rule. So now let's go down to problem 5. Problem 5 is the example that applies this rule. So anytime you see a diagram like this on a standardized test, we have a circle. Notice that from point S to point R, this is a tangent because point S is tangent to the circle. Likewise, we have another tangent, segment TR. Okay, and point T is the point of tangency. When these two tangents meet at this common point on the outside, from this common point to each point of tangency, we have congruent segments. So these two segments have the same exact measure based on that theorem. So we can set this measure equal to that measure. And this is how you form your equation. So 2 times x plus 4 is equal to 26. And then we just simply isolate x. First we move forward to the other side of the equation. That gives us 2 times x is equal to 22. And then we divide each side by 2. We find that x is 11. Let's go to the other side at this time to do a few other example problems. So if you look at the first section, 1 through 3, we don't apply that concept. But if you go to the next section, for problems 4 through 6, you see some tangents to a circle, all right? They have a common external point. So looking at problem 4, we're told that the points K and M are points of tangency. Find the value of x. All right, so this is a tangent line segment, and this is a tangent line segment. And they both meet at the same external point. So from point J to point M is the same exact measure as going from point J to point K. So these two segments are congruent. If they're congruent, we set their measures equal. So we can set 4 times x plus 7 equal to 7 times x minus 8, and then solve for x. And we'll do this quickly. I'm moving the 4x first. That leaves 7 equals 3x's minus 8. Add 8 to both sides. We get 15 equals 3 times x. We know mentally we divide each side by 3, and we find that x is 5. We're through. Same for problem 5. We have two tangents that meet at a common external point. They are congruent. So we can set their measures equal. All right, let's do this. We see a square. It's okay. So let's set 3 times x squared minus 10 equal to 17. So what would you do to solve this? Move the 10 to the other side with this like turn by adding 10 to both sides. So that leaves 3 times x squared on the left, and 17 plus 10 is 27. What is the next step? You don't deal with the square yet. You want to get rid of the 3, the coefficient. To undo 3 times x squared, we divide each side by 3. So that leaves x squared on the left equal to 27 divided by 3 is 9. Now we can undo the square by finding the square root of both sides. Once again, we get x is equal to both the positive and negative of 3. In this case, we can use both the positive and the negative. Because if you take the negative term and you square it, it becomes positive. So it can be both the positive and negative of 3. And just plug them back in to get your final answer. You do the same with problem number 6. And set those two measures equal, then isolate x. And likewise, we look further down at problems 10 through 12. It's the same concept. So I feel like all of you can complete those problems on your own. Okay? But let's deal with one new lesson. One new lesson, and I think it'll be simple for you guys. Just listen, and I think you can learn it. Landon, cut it off.